Paper in its different forms is something we take for granted today in Europe. We can make do without many things, but irrespective of age, we've become dependent on paper products. We hear a great deal about today's so-called paperless society, but despite this, never before has so much paper been produced. Paper is part of our lives today. And raw material is something we need a lot of. Each year, we consume 1.5 million cubic meters of timber at Murrum. Activity at our timber intake bays goes on around the clock. In order to satisfy our needs, a fully loaded truck must arrive at the mill every 10 minutes. However, not all our raw material is from pulpwood. A large amount of the felled timber goes to one of the many sawmills in southern Sweden, where the timber is sawn into planks and boards. During this sawing process, there is a certain amount of timber surplus to requirements. This is reduced to chips and subsequently used by us in the production of paper pulp. The pulpwood delivered to the Murrum mill is stored in our own yard. The stock in hand is sufficient for approximately 30 days. Before the timber can be cooked into pulp, it must be reduced into chips, but first of all the bark must be removed. This takes place in the barking drum. We subsequently use the bark as fuel for our steam boilers, and this means that today we need only use oil as a fuel source under exceptional circumstances. When the bark has been removed, the timber is cut into chips. The chips are transported by conveyor to our digesters. We have 5 for hardwood and 5 for softwood. Here the chips are cooked under high pressure in a liquid that we call white liquor. During the cooking process, the cellulose fibers are separated from the other constituent parts of the wood. Approximately 50% of the raw material is fiber, which is used in the production of paper pulp. We use the remainder, the lignin, in our soda recovery boiler for recycling and for the production of energy. The cooking process takes approximately 4 hours, and when completed, the fibers and cooking liquid are forced by the pressure in the digesters into a blow tank. Heat is released in conjunction with this blowing phase, and we take advantage of this and use it as one of our sources of energy. From the blow tank, the pulp is pumped onward to a primary screening room, where chips that have not been completely cooked are separated. These are what is known as coarse reject screenings, and they are returned into the process to be recooked. After the primary screening, the pulp is transported to a filter wash, where it is washed in 4 stages. We do this to separate the cellulose from the lignin, liquor, and other chemicals. The residue goes back into the system. This is both economically and environmentally sound. The cooking liquor contains a great deal of water. Most of this water is removed by evaporation, and the liquor is then burnt in the soda recovery boiler. The task of which is to, on the one hand, convert the chemicals so that they can be used again, and on the other hand, to produce steam. The soda recovery boiler supplies 80% of the steam power we use. The evaporated water is treated together with the condensation water from the cooking process in a purification plant, a so-called stripper column. From the bottom section of the soda recovery boiler, the chemicals run out in molten form. They are dissolved in water, and the result is a solution called green liquor. The green liquor then reacts with quicklime, from which we again obtain the white liquor. We produce the quicklime ourselves in the lime kiln, where lime that has been previously mixed with green liquor is re-burnt. We produce our own electrical power by means of 2 counter-pressure turbines. The electrical power we produce is sufficient to supply a medium-sized Swedish town. With the help of this heat exchanger, the surplus power produced is supplied to Karlshamns power station, with whom we have a special arrangement. We can really claim to be working with biofuels, both as a saleable product and as a source of energy. The production of paper pulp also requires a tremendous amount of water. We take the water from the Murrum River. At this pumping station, we can pump more than 1,000 litres of water per second, which is then piped to our own filtration plant. The water is purified here before being used in the manufacturing process. The degree of purification depends on exactly where in the process the water is to be used. In this context, it is perhaps worth mentioning that we also produce our own drinking water. Now back to the paper pulp. When we left the actual production process, we had come as far as the washing phase. This is what the pulp looks like at this stage. It is brown and not at all as white and clean as our customers want it. We must therefore bleach the pulp. Bleaching is a complicated chemical process where we use chemicals that react with the pulp in different bleaching stages. Between each bleaching stage, the pulp is washed in filters and in washing presses. When bleaching, we use the latest techniques in order to minimize the effect of the discharge on the environment. We therefore mainly use oxygen and chlorine dioxide for bleaching purposes. Most of the bleaching chemicals arrive at the Murrum mill by rail, but we manufacture the chlorine dioxide ourselves in this plant. We must, however, still use a small amount of chlorine in the bleaching process, but despite this we can say that the Murrum mill today is as sympathetic to the environment as it is possible to be given today's techniques, while still maintaining the same high quality of pulp. All of our operations are carefully controlled by laws and regulations. The National Franchise Board, which is a sort of environmental court, has prescribed how much we are allowed to discharge into the air and into the water. It is then the County Council's responsibility to check that we do not exceed the prescribed limits. The Murrum mill has invested a great deal of money in measures to improve the environment. In the last few years, this amounts to some 400 million Swedish crowns, or 35% of our total investments, a large proportion compared with other industries. To reduce the discharge of sulfur dioxide and dust from the soda recovery boiler and the steam boilers, we've installed both electrofilters and a scrubber. The scrubber is located in the actual chimney and effectively washes out the pollutants in the exhaust gases. For odorous gases, there is also a gas collecting system from which the gases are returned to the lime kiln where they are burnt off. The lime kilns are also equipped with electrofilters. We have also invested a great deal of money in new modern techniques for the supervision and control of the various processes. Monitor screens and computerized control techniques have replaced regulators and the different types of measuring instruments. Our personnel are trained not only in the process techniques, but also in environmental questions. All this to safeguard the environment. We continually take samples of air and water. The samples are analyzed in our laboratory to ensure that discharges are always held at the lowest possible level. The discharge into the sea is made through a 6-kilometer-long pipe out in Pukovik's Bay. The discharge is spread through small holes in the pipe, diffusers, in the last 2 kilometers of the pipe. Again, we do all this so that the environment is affected as little as possible. But let's return to the pulp. After bleaching, the pulp is in principle ready. But first it must go through a final cleaning process. This takes place in the post-screening room with a hydrocyclone, where heavier small particles such as sand are removed. After the final cleaning, all that remains is to extract the water from the pulp. The final product should only contain 10% water. This is achieved by means of a drying machine. First, we feed the pulp from what is known as a head box to a moving wire, where a large amount of the water runs off or is removed by suction. After this wet stage, the pulp comes to the press section, where it is squeezed between press rolls to extract more water before going on to the steam-heated drying cylinders. The pulp now passes into the fan dryer, where warm air dries it to the required moisture content. The paper pulp is now ready. All that remains is the cutting into sheets, which takes place on this large guillotine. The pulp sheets are stacked in bales that are then compressed in order to take up as little space as possible for transport. Each bale weighs approximately 200 kilos. The bales are wrapped, stacked, and bound together in packages of 16 bales. We do this to make it easier to handle the pulp when loading and storing. The pulp can be transported by truck, rail, or by boat. The harbour at Stillarid is ice-free the whole year round, and we can quickly reach our customers, the paper mills on the continent, either by means of our own long-term charter ships or other vessels that our shipping company, Surda Shipping, have chartered for single voyages. Murham is a large mill. We have an annual production capacity of 375,000 tons of pulp, produced on 2 different lines using softwood and hardwood. Every year we sell pulp to a value of 1.5 billion Swedish crowns. Most of it is for export, which makes us one of the largest suppliers to the European market. We ourselves answer for approximately 10% of the pulp exported from Sweden. Through hard work and a concentration on high-quality standards, we have established a good reputation on the market. In our laboratory, tests are continually carried out on our pulp. Here, the fibre length is being checked. The Murham mill also has a special laboratory with a research and development department that serves all of Surda's 3 pulp mills. Here we have equipment to make detailed analyses on the relation between the quality of our pulp and the environment. We also have our own small-scale digester, where we can make small quantities of pulp in order to test new techniques. Important as these techniques are, without a competent and responsible workforce, the Murham mill couldn't function. There are many different categories of work here, and they all contribute to keeping the Murham mill running at the peak of efficiency. A process industry of this type must function day and night, high days and holidays. Our knowledgeable supervisory staff for the 6 different shift teams oversee and control the whole operation. The criteria for efficient preventive and remedial maintenance for buildings, machines and other equipment are very demanding. There are also skilled workers in the maintenance sectors of construction, mechanics, electronics, instrumentation, transport and warehousing, who together with the staff from the drawing office and maintenance planning cope with all of this. At the shift and the day laboratories, it is vital to constantly check the effect of our processes on the environment and the quality of our product. Our telephone exchange is housed here in the office building. The factory and shift management groups are also located here, together with operation and maintenance engineers and the administrative personnel. Every morning we have our morning prayers, that is to say, a meeting where the previous day's production and any problems are discussed. We work as a team, and all participants are equally important. We are well prepared and equipped for the future, both in terms of process techniques and personnel. In short, Murham is a mill for the 1990s.